Hello everyone, myself Rajni, and today we are going to discuss about a very interesting topic, that is matter around us. So, in this video we will learn about firstly what is matter and what are its types. In this video we will discover three types of matter, that is solid, liquid and gas. And lastly, we will talk about the particle arrangement and behavior in each state. So, let's begin. Firstly, what is matter? Matter is anything that has mass and occupies space. It makes up everything around us. So, the water we breathe, the chair we sit on are all the components of matter, different types of matter. So, here's a question for you all. First question goes like this: can you stir a solid? Why or why not? Next, can you hold a gas? Why or why not? We will take this question in the end of this video, as after going through the content about solid, liquid and gas, you will be able to answer these questions. So, till then, you can hypothesize the answer of these questions. So today, we will be able to sort a range of everyday substance under three states, that is solid, liquid or gas. And then we will be able to name the properties of each state. And lastly, we will be able to create a connection between particles, arrangement, and substance properties. So let's begin. So before beginning, here's a small exercise for you all. Sort the following substance under the three states of matter, that is solid, liquid and gas. Here are some pictures depicting some substances. Example like lunchbox, notebook, juice. So you have to put these substance under categories, that is solid, liquid and gas. Hope so you all were able to categorize the substance. So here's the answer for that question. In solid, we can put book, a stapler, lunchbox, and a board in solid category. In liquid category, we can put juice, water, and cold drink. And in gaseous state, we can put air. Moving to the first state of matter, that is solid. Firstly, particle arrangement and behavior. As you can see in the diagram, the particles in the solid are tightly arranged and follow a specific pattern. So, the particles of solid are tightly packed and are arranged in a specific pattern, and they vibrate in a mean position when force is applied to the solid. Linking the particle behavior to the properties, we can conclude that as the particles in the solids are tightly arranged and follow a specific pattern, they are rigid. Solids have fixed shape, fixed volume, they can't be compressed and they can't flow. For example, chair. We all sit on the chair. When we sit on the chair, we apply some pressure on the chair due to our mass. So, does the chair compress? No, the chair didn't compress. That means solids are not compressible. So let's move on to the next state, that is liquid. Firstly, particle arrangement and behavior. As we can see in the diagram, in liquid state, the particles are randomly organized as compared to the solid state particles. So, in liquid states, particles are close together but has no regular pattern. They have little free space between them and they slide roll past over one another as they have spaces between them. We can link the particle arrangement to the properties and conclude that as they are spaces between the particles, they are not rigid, they have no fixed shape as they are randomly arranged, but they have fixed volume, and the liquids can be slightly compressed and the liquids can flow. For example, if we take water in a jar and place 3 to 4 glasses nearby, when we pour the water in the 3 to 4 glasses, the water easily flows and the water take the shape of the container they are put in. In the jar, when the water was in the jar, it was taken the shape of the jar. As soon as the water is distributed among the different glasses, the water takes the place of the different containers they are poured in. So, we can conclude from this experiment or this activity that liquids can flow, they have fixed volume, but they didn't have fixed shape. They take the shape of the container that they are placed in. So, let's move to our last state of matter, that is gaseous state. So, from the diagram of the particle arrangement, we can all see that as compared to solid and liquids, the particle in the gaseous state are widely spaced and they are randomly placed as compared to liquids also. So, moving to the properties, the particles in the gaseous state are widely spaced. They travel in straight line until they bounce off another particle or a surface. They move around quickly as they have larger distance between the particles. So, linking the properties and the particle behavior, we can conclude that gases are not rigid, they didn't have any shape nor fixed volume, they can be compressed and they can flow. We can take the example of the cold drinks. In cold drinks, the CO2 gas is compressed, and when we open the lid or the cap of that can or the bottle, we can hear a fizzy sound. That is, the gas get released in the atmosphere. Secondly, to prove that they didn't have fixed volume and fixed shape, when we spray a perfume in one corner of a room, after some time we can smell that perfume far away. That means the particles traveled the whole room, the particles traveled from one place to another and covered the volume of the whole room. So here's a riddle for you all. The riddle goes like this. Krishna found a mystery substance which has the following properties. Firstly, it flows. It can be slightly compressed, it has a fixed volume, and it follows the shape of its container. So you have to guess this mystery substance, and after guessing the mystery substance, you have to draw the particle arrangement of this substance. Hope you all have guessed the mystery substance and drawn its particle arrangement. So the mystery substance was liquid state. So, as we have already discussed, liquids can flow, it can be slightly compressed, they have fixed volume, and they take the shape of the container they are placed in. So, the mystery substance was liquid. Moving on to the next, a quick recap of the whole video we have done. Firstly, solid state. In solid state, particles are tightly packed and arranged in a regular pattern. The particles in solid vibrate in their mean position when force is applied to them. Examples of solids are a book, a chalk, a chair. Moving to the next state, liquid state. In liquid state, particles are not arranged in a regular pattern but have a little space between them. They slide and roll past one another. Examples of liquid are water and juice. Moving to the last state, that is gaseous state. The particles in gaseous state are widely spaced and fill the space they are in. They move around quickly, and the examples of gaseous state are wind and steam. So, here's the two questions which we have put in the starting of the video. So, hope you all have hypothesized the answer of these questions. So, first question goes like this. Can you stir a solid? Why or why not? As we have already discussed under the properties of solid, that in solid the particles are closely packed to one another and they have little to no space between them. So it is not possible to stir a solid. Moving to our next question, it goes like this. Can you hold a gas? Why or why not? As we have studied the properties of gaseous substances, that it take the shape and volume of the container they are stored in. and they have a wide space between them. And we have already studied that yes, we can store the gas in a container as they are compressible. So yes, we can store or hold a gas after we compress that gas. For example, CO2 is compressed in cold drink bottles to preserve them. So yes, we can hold a gas, and no, we can't stir a solid. So, and last, think about this. You might have observed your parents heating water on a kettle. What do you think is happening to the particles in a liquid as it becomes hotter? So you can see in the diagram given in the slide that as we are providing heat to the liquid, that to the water start boiling. As the water start boiling, the water is converting into water vapors. That is, the liquid is converting into gaseous state. And we can see in the diagram that the gaseous state or the water vapors are coming out of the kettle from the vessel. So, yes, phase transformation is possible when we provide some heat to the substance. For example, in this case, we provide heat to the liquid and it get converted into gaseous state. So, that's all from my side. Thank you for watching this video.